Okay, on this problem, I've got a particle that follows the curve y, oops, equals x minus 1 over 400 x squared, like so, where x and y are in feet. Okay, and then it says if the velocity of the component in the x direction is, so that means if x dot is 2 feet per second and remains constant, which would mean that x double dot is 0, it wants me to find the magnitude of the velocity and acceleration when x equals 20. So when x equals 20, let's go ahead and figure that out as long as we're at this. So x equals 20 minus 20 squared all over 400. So that y then becomes 19. Okay, so now that we've got that, we're going to go through and we're going to figure out, we're basically going to take a time derivative of this first equation. So I go from y to y dot, I go from x to x dot, 400 is left alone, and again I have x squared, okay? So basically that's x times x, okay? So I can say x dot times x plus x times x dot, which again basically equals 2x dot x. Okay. Um, so then from that I can take a second time derivative, y double dot, that goes to x double dot minus 1 over 400 times, now this will be 2, so I'm going to pull that 2 out. That'll make this 200 there, and then I'm going to have x double dot x plus x dot times x dot, like so. Okay, now I'm going to go ahead and plug in everything that I know here, and I'm going to say, okay, well then x dot equal, excuse me, y dot equals x dot, which is 2 minus 1 over 400 times 2 times x dot, which again is 2, times x, which is 20. And from that, I get that y dot equals 1.8. I can do the same thing with x double dot. I know that x double dot is 0 minus 1 over 200. I've got an x double dot, so the first term goes to 0, and then I've got x dot squared, which is just plus 2 squared, and from that uh, I get a negative 0.02 feet per second squared. Again, x double dot is 0, so this y double dot, this is the only acceleration that I have, so I can go ahead and put that in there. To find my velocity, I just take the square root of the sum of the squares, which is that 1.8 that I got for y dot, plus x dot, which is given to be 2, so I get 2.69 feet per second. So again, taking what I know, taking time derivatives, keeping all other variables, leave them alone, just differentiate with respect to time and calculate based on what I know.